Okay, good morning, everyone. We will start with a 3 minutes quiz today. So just take 3 minutes to complete these two simple questions. It should be straightforward, just to review what we learned from last lecture. And then I will quickly review the answers before we move on with the rest of chapter 7. Okay, let's have a look at the answer. The first question, the range of an n-bit unsigned binary number compared to the range of an n-bit signed binary number. So if it's n-bit unsigned, then the range should be 2 to the 0 to 2 to the power of n minus 1. So for example, if it's 8-bit, the range should be 0 to 255. So that's the easy part. So if it's a signed number with n bit, so we have to know that 1 bit is used for the sign bit. Most significant bit is the sign bit. Then we are left with n minus 1 bit. So that's how we work out the range. So minus 2 to the power of n minus 1 to the upper range is 2 to the power of n minus 1 minus 1. So for example, if it's 8-bit, so we have to remove 1 bit here. So that's for the sign bit. And then we have 7-bit left. So 2 to the power of 7 minus 2 to the power of 7 is minus 128. To the plus 2 to the power of 7 minus 1, that's 127. So last lecture, at the end of last lecture, I had a question, very good question. I can't remember who asked that. So that is why it's a negative 128 to plus 127. So it's the asymmetrical. So here, so minus, we have minus 128 to minus 1. So all those numbers, so in total is 2 to the power of 7. So 128 numbers, negative numbers, they are all represented by the binary number with the most significant bit equals 1. So that's half of the full range. On the positive side, we have to include the number 0. So 0, when we use a binary value to represent it, it also has the most significant bit, which is a sign bit equals 0. So we can't go up to 128 plus 128. That will requires an additional bit. So that if you use that to represent the positive value, you will actually have an overflow, which means the magnitude bit will overflow into the sign bit. So that's why it's asymmetrical. The range should be minus 128 to plus 127. So that's in total. How many numbers do we have here in total? So it's still going to be 256 different values. It's like we just shift the range from positive 0 to 255 to minus 128 to plus 127. So the range is shifted, but the total number that we can represent is still 256 different numbers. So the next one is also just to test the, we remember the three different formats. So it's 3 different forms, not format, obviously 3 different forms. So convert the decimal value minus 21. So how do we do that? We have to do first step, use a binary to represent the positive value, the positive magnitude of this minus 21. So plus 21 is 0, 0, 0, 1, 0, 1, 0, 1. So that is the positive value, the magnitude. So for true magnitude, to convert the positive value to negative value, we only need to convert one bit, that is the sign bit, So the sign bit previously is 0, now you get 1. All the other magnitudes remains the same. For 1's complement is the whole lot, the whole value, we need to flip them, the whole values. So every bit need to be flipped, including the most significant bit, the sign bit. So flip all bits here, we get this 11101010. That's 1's complement. So for 2's complement is that we have to do 1's complement first and then plus 1. So add another 1. So that's our 2's complement form for the negative minus 21 value. If it's plus 21, if it's a plus 21, so the form for all the, so these three forms, for positive values, they are the same. So this plus 21 are used for true magnitude, 1's complement, 2's complements, positive values. So for positive values, there is no difference among these three different forms. Only when we need to convert the negative value, they are different. Okay, hopefully you all get that. So that is our 3 minutes quiz. So we are getting quicker.